divided by. I'm going to leave the first 4 factorial the same. I'm not going to change it. And the other 4, I'm going to write it as 4 times 3 times 2 times 1. And then 2 factorial, 2 times 1.
It's gonna cut off, I know.
Okay, good morning. Okay, we're just going to do some prep for the core practical. The core practical will obviously be done after LIA, but I think we just need to do a little bit of that. So we're just going to go through some of the details of the core practical, give you a little bit of time to make sure you've read it and make sure you understand what it is. I think the only thing that you really need to do beforehand, apart from annotating the method with any extra details, will be to draw results tables. So it's not going to take you the mind of it. I'll also set some prep with some titration, the core practical stuff that you need to do like today. Then you can get started on that. Okay, so it's Andrew here. So I'm just going to, and the work, the method, and essentially the work that you're going to have to do when you've done the practical onto OneNote. So if you want to open that. Also, I won't show any videos on this. Otherwise, I'm pretty sure my internet is too laggy for that kind of thing. Let's sort of try. Okay, so a dilution of a solution, and you're then going to do a titration. So it is kind of bringing together a lot of the essential parts of this practical. So there's a couple of bits that we're going to be looking at in this. Is basically, can you follow instructions? Hopefully you should be fairly familiar with the processes. Can you identify any issues, and can you the method does not contain all the details, so I written method, and ultimately, can you get some accurate and precise data and sufficient data? During the things that I'm going to have you made up your volumetric flask. Now, obviously, I think what we'll do is we'll work in pairs again, but you've both got to agree. When it comes to accurate pipette filling and burette reading, so the first part will obviously be you both got to agree when you think you've got the meniscus on the line. And the second two bits, I'll judge you independently of these. This is kind of
Cool, man.
so carefully make it up. Then you show me at this stage, and then you stopper, mix, etc. I'm going to leave the video. You can watch that in your own time, is going to be the titration. So just like you did on Tuesday, I think it was, you're going to need to accurately take the pipette, take 25 centimeter cubes of the solution, make sure it's accurately on the line and there's no bubbles, and you've shown that you've washed out both of these things beforehand, rinse them with the solutions, and then you're going to do the same with your burette, removing the funnel, making sure there's no air bubbles down the bottom bit down here, take an accurate reading at the beginning, and then you're going to add it until the end point, the color change, and then you can do it. So the first time do a rough, and then obviously the next time do it more accurate. You're going to try to get valid results by using a white tile so you can see the color change, but also when you're getting to that end point, making sure it is drop by drop. I thought you guys were getting quite good at it on Tuesday. So, you know, hopefully by the time, I know it'll be after LIA, so you might have forgotten it, but hopefully it should be fairly standard for you guys. When I've stopped talking, you can have another look at the little video by the RSC, just to remind you of the core practical. Also, I'd recommend like maybe after LIA on the Monday night or something, just to refresh yourself before the practical. We're looking at, obviously there's different types of indicators and they have different pH changes. So depending on where, and essentially it's when we got the vertical part, where your endpoint will be. Now, not all endpoints are 7. Sometimes the endpoint might be below 7, above 7. So an indicator needs to be selected. We've talked about this, different, you know, endpoints. Methyl orange, what you did the other day was the orange between the yellow and red. And I think it's generally depending on which way we're going for phenolphthalein. So if we're starting off with acid on the left, colorless, the pink should be very faint. It can even be a little bit fainter than this one here, okay? So that's why you have the white tile. If we're going the other way and adding acid to an indicator, it should be the one drop that takes it from a very painful. Obviously, if you add a lot more, it stays colorless, so you can't tell how far you've gone. So it is about being really careful about getting it. Reminder about reading burettes. You know, it needs to be at eye level because you can see how your reading will be different in each case. In this case, it's 19.70, not 6 or 8.0. You're taking a reading, we're reading downwards in a burette. So this is 2.10 and this is 23.85. Notice I'm always reading to 2 decimal places in each case. That is essential as well. I will get you to draw the results table quickly, or insert a results table on the OneNote in a minute. It's one of the things I want you to have done before the practical, so that when you come to do the practical, all you're doing is writing in your results, and it will save you a lot of time. So you can see we've got beginning reading, final reading, and then this is the difference. First reading should be done quickly, because then you can do the next couple ones much more accurately. Personally, I think you should also have the uncertainties in your read 2 decimal places, ending in 05 or O. This is pretty standard. The other thing that we can see is the idea of what is a concordant result. I can't remember what it says on the thing, but normally you should be looking for concordancy within plus or minus 0.1 of each other. So I guess quite often they sometimes say 0.2. So this can be this reading here could be, say you had 22.9, and this was 20, let's say it's 23. This reading was 23.00. What the error means is it actually could also be 22.9. And this could also be 22.9. So you could argue they are both concordant if they are within 0.1 of each, plus or minus +1. So concordancy tends to be plus or minus 0.20 of each other. I'm not sure if the method tells you what the concordancy is, but you should. And then you only ever use the concordant results to calculate your average, which you'll use in your analysis. So why do we, so just jumping back here, these are our absolute uncertainties. And because they're the same units, when we take a difference, we can add them together. So that's why we end up getting this. And again, for just like we did with the mass, you know, we can add the uncertainties together to get our final uncertainty in each case. I guess it's also worth thinking about what are these uncertainties in a titration. It is quite hard to tell exactly where your readings are on a burette, but it's deemed that you can generally say it's either on the line or between the lines. Anything more than that you can't do. So normally written on the side of a the apparatus. So in this case, they're saying it's 0.3. I guess also a lot of things are calibrated at a certain temperature. So even the burette calibrated at 20 Celsius, this would be calibrated 20 Celsius, and the, you know, thermometers and things. I guess one of the big ones to really say that is your visual recognition of the endpoint. So, you know, that could be a drop or two. You probably noticed between when you did it on Tuesday, there could be a slight difference in that. Okay, I'm going to stop talking a minute. So what I want you to do now is go to the OneNote and you're going to read through the method and make sure it all makes sense. And what I want you to do is draw a results table on the OneNote immediately. During the practical, I'll remind you this, you'll obviously follow your method and any changes you've made. And you're going to show me these 3 bits to prove that you can do them correctly. And afterwards, you just make sure that's handed in. So can you go to the OneNote that I've given to you? So, there we go. So what I'd like you to do first off is just read through the slides that I've just gone through, and I want you to watch the 2 videos. One's just a reminder about how to dilute a solution accurately using a pipette and a volumetric flask. And then the second one is just a reminder about titration. So do watch it, even though I think most of you know how to do it. And so just remind you about some of the key bits that I want you to think about. The rest of it is fairly standard, just about tables and stuff like that. Then once you've done that, you might just want to look at how I'm going to assess you. You can see here some of the bits that you're going to need to make sure. Read through the method, just add some annotations. I think if you don't have an iPad, just add a text box and add some things on it. So, you know, whether it's talking about the funnels. Okay, I pointed that out to a few of you this lesson. I think there's some key bits in here that you would then annotate the method, just put some text boxes in if you need to, by the side, some extra key points, and then draw your results table. Once you have done all that, there is, or will be, some prep related to doing back titrations. Have I sent this out? Yes, sorry. No, I haven't sent it out. So back titrations are kind of slightly more tricky titrations. They require a little bit of sort of going backwards. So trying to work out how final amount was in there. Okay, these are a lot more tricky. So I'll put that there now. Okay, so feel free to turn your cameras off. I will actually open the meeting rooms. So if you want to work together and talk about things, or just want to talk about things, but if you're not too sure about stuff, you're free to do that. Let me remember how to do this. Okay. In fact, I've opened 16 rooms. You can all go in individual rooms if you really want to. So feel free to go join a room. If you need me to come and join you and help you, just shout, or you can stay there with your camera off if you prefer that.
Volumetric pipette. To use the pipette, place the pipette in the liquid to be marked on the pipette so that the liquid required to force the liquid out, as pipettes are designed to deliver the exact amount of liquid, and there may be a small amount of liquid remaining at the end. Remove the pipette and follow the same procedure as before, filling the liquid out, as pipette 50 milliliter volumetric flask. Allow all of the liquid to flow out of the pipette. Do not use the bulb to force the liquid out, as pipettes are designed to deliver the exact amount of liquid, and there may be a small amount of liquid remaining at the end. Remove the pipette and follow the same procedure as before, filling the volumetric flask with solvent, again monitoring the meniscus until the exact volume is reached. You've now learned how to prepare a dilute solution from a stock solution. To see how to prepare a stock solution, you can view our solution preparation video at moles in our dilute solution. Knowing our solution, inserting the pipette into the solution. This is because you do not want to contaminate your stock solution. In this case, I'm using an Erlenmeyer flask. Notice that I have clearly labeled the flasks to adhere to proper laboratory safety protocol. Use the pipette. Place the pipette in the liquid to be
In this acid-base titration, a standard solution of sodium carbonate will be used to determine the exact concentration of a dilute solution of hydrochloric acid. An indicator solution will be used to help find using the funnel approximately 50 centimeter cubed of your stock sodium carbonate solution into a dry, clean beaker. Rinse the burette several times with distilled water. Using the funnel, add a little of the sodium carbonate solution to rinse through the burette above and below the tap. Discard the rinsings and repeat the step 2 more times. This makes sure that you do not dilute the solution when you fill the burette. Fill the burette with sodium carbonate solution above the 0 mark and remove the funnel. Using the tap at the base of the burette, allow the sodium carbonate solution to flow into the beaker until the level of liquid is at or a little below the 0 mark. Ensure there are no air bubbles in the nozzle. These can be removed by just running a little more solution through the tap. Next, you'll need to record the level of the solution in the burette. It can be tricky to see the meniscus clearly. It helps to hold a piece of white card behind the burette so that it lights up the bottom of the meniscus. Take the first burette reading and then 2 or 3 times with some solution into the rough titration. This is to determine roughly how much of the alkaline solution is needed to neutralize the acid and will give us an approximate value of the endpoint. Start by running the
Helen,
Hi.
are you able to done the table and things on your CP3 pupil, or are you doing it on paper at the moment?
Oh, I'm doing on paper.
Okay, that's fine. Ollie, are you able to open yours? I was looking at yours. It's a bit.
My one is broken. I need to create like another one on a separate document.